Hello, everyone. Welcome to the Designing for High Performance in Power BI session. So my name is Siva, and I'm a Principal Group Manager in the Business Application Group. And then we also have Phil, who is from the Power BI Customer Advisory Team. Phil various solutions to the customers so that we are going to leverage our best practices, which we have learned from interacting with various customers. And we're going to share how do you design for high performance in Power BI in today's session. So with that, I'm going to hand over to Phil.
Cool. Thank you, Siva. So what are we going to look at today in this session? Let's have a quick look at the agenda. So we're talking about designing high performance reports in Power BI. So what we want to focus on today is to look at the main areas where your choices can affect performance positively, obviously, or negatively as well. So a lot of the things we're going to be talking about today are what we've learned from the engineering side of things, because a lot of performance issues are related to design choices, things that you do. So my role in the Power BI CAT team, I'm often confronted with situations where a customer has said, hey, my reports are slow. They're taking 30 seconds or more to load. And when we spend some time having a look at that and going through a lot of the tips that we're going to share with you today and apply the learnings, we can often find that we can get query speed down to sub-second simply by changing the approach and the design. So absolutely, for a lot of things, you can control this. Power BI is a very flexible system, which is a double-edged sword. It's good that high levels of flexibility give you the ability to tune and really optimize your models, but of course a lot of flexibility means that it's also fairly easy to go off the rails as well. We try our best to put guardrails in for you, but you can equally make some design choices that will mean your report runs very, very slow if you don't apply some of these tips. And of course, when you scale up to enterprise size solutions with very large data volumes and lots of users, think of Monday morning when you have 10, 50 or 100 users all hitting a report that sits on several hundred millions of rows, then you really need to make sure everything is tuned efficiently to get the best results. So what are some of the areas that we can influence and affect performance for both shared and premium? So, poorly designed reports and dashboards. So perhaps what we're talking about there is the visual layer, the relationships, the number of visuals. These are the sort of areas we're going to be talking about. Inefficient data models. The relationships, the number of rows, the number of tables, all these things can influence not just query speed, but how long it takes data to be loaded into the model and the size of the model at rest. Inefficient calcs, DAX expressions that can be a lot more complex than they need to be, particularly if the data model isn't optimized. What that can mean is you have to write a lot more code, and that code has to execute at runtime and use a lot more CPU and memory of the server that it's sitting on. Inappropriate use of direct query and import. Now these two storage modes give you pros and cons. Direct query is very good at certain things. Import is very good at other things. And if you use the wrong storage mode, then you will definitely see some negative performance characteristics in your engine. Data loading, we're going to look at Power Query and what are some things that can trip you up in Power Query and M. Security with row level security. Data source network latency. Is your data source in the same location as your Power BI tenant? We have seen situations where people have got their data source on the opposite side of the planet to perhaps where their reports are being delivered for, things to consider. And obviously a gateway can play a big role in a lot of these things as well. So you can control many of these elements that we've just discussed.
So thank you, Phil. So you learned a little bit about introduction in terms of what we're going to cover in this presentation, as well as some of the common challenges, what we have learned from architecting solutions. And then you learned quite a bit with respect to Power BI Premium and when to use it. Before we deep dive a little bit more into the various topics that Phil talked about in the introduction in terms of poor designs with respect to data models, reports, dashboards, and when to use direct query versus imported data models. And then the challenges you might have run into with respect to row-level security or network. We want to give you a little bit big picture in terms of the key components of Power BI so that you understand a 50,000 view of what are the key components and where are the potential bottlenecks that you might encounter. So that's what this architecture and configuration section is going to cover. And as we're going through these sections, if you have questions, please type them in the chat window so that Phil or I can respond to your questions. And we will definitely try to take some questions towards the end of the presentation. But please type your questions so that we can answer the questions in the chat window as well. OK, so with that, in this section, what we want to make sure essentially is there are a set of reports which you're authoring in Power BI Desktop, and then you're publishing it to the service, right? And we want to make sure that you understand what are the additional considerations that you need to take care as compared to what you're doing it within the desktop. This is giving you an overview with respect to how the entire system works in the Power BI service overall. Okay, so the key goals of this section. So one is, how do you choose the storage mode? What are the key business problems we are trying to solve? And how do you decide on which storage mode to use? In addition to that, how are you reducing the latency, the throughput, and how are you utilizing the efficient resources in the Power BI service? So that's essentially some of the goals we want you to walk away from this particular section. OK, so the diagram which you see here at a high level is the Power BI. So on the left-hand side, you see that you have the Power BI desktop, and you can import data from cloud-related data sources or on-premise data sources. It could be analysis services, SQL Server, Oracle, Teradata, some of the on-premise sources, or even the cloud sources, right? And then once you have this, then you upload your reports into a workspace. And with ALM, which are some of the features that have come in recently, you would follow the best practices on ALM. And then you are essentially sharing these reports. So as you're doing this, when you upload this report is essentially being served from an analysis services that's hosted by Power BI in the service. OK, that's where you will have the data model getting hosted. And then the reports and dashboards are actually getting the data directly from this analysis services. And then the end users are consuming it from the web or from the mobile devices overall. OK, in between, when you have an on-premise data source, you do need to set up an on-premise gateway, and so that you can do a scheduled refresh if it's an imported model, or if it is a direct query or a live connection, direct query to SQL Server or some of the data sources which we support. Or it could be a live connection to analysis services where the credentials automatically flow through. So you do definitely need an on-premise gateway. So this is giving you an overview of various key components that are involved when you share Power BI set of Power BI reports or dashboards to your end users. OK, now where is the time being spent? So there are multiple components which are there in the Power BI system. So the first one is essentially the time could be spent directly in your data sources, right? So you can take a classic example where you're doing a scheduled refresh. So when you do a scheduled refresh, that data has to be, think of it as this is an imported data model that resides in the Power BI service. If it's an imported data model, then when you're doing the scheduled refresh, then the data Power BI has to go and retrieve this data from the cloud data source or on-premise data source. So that could take time. So essentially the bottleneck could be in your data sources. So that is one of the cases. Then the second one is could be a live connection or a direct query, right? When you have these two, then when you query Power BI, then Power BI is directly getting the data from your data source, right? Because you don't have an imported model. There is some caching which is there, but like because since these are direct query, we need to go and fetch the data directly from your data source. So there could be bottlenecks in your on-premise or cloud data sources in that particular case. So that could be one of the first bottleneck which you might encounter. The second area is more in terms of the gateway, right? So if the gateway is not optimized and if it's not scaled out, you might potentially encounter a bottleneck in the gateway. So think of it as you have hundreds of data sources in the gateway architected, right? Do you have the right configuration for the gateway, right? We have seen personally, like some of the customers having like 200 data sources in a single gateway, right? So in those scenarios, we need to make sure that you have the right configurations for the gateway machine, or you might want to split this up into multiple machines where the gateway officially supports this. Are you monitoring the gateway, resource usage, and are you optimizing it? This could be the second bottleneck. Then the third bottleneck is network latency, right? So you might be familiar that Power BI, all of the data is typically hosted in a particular location in a data center. Now, when you upload this, your report, essentially, you are essentially uploading it to the Power BI service, right? So you see this arrow going from the Power BI desktop into the workspace in the service. There could be network latency when you're uploading it. There could be network latency when end users are consuming the report into Power BI. So if you, for example, if you take Microsoft, the data center where all of the data for Microsoft users at a tenant level is being hosted in the US region, but we have Microsoft all over the world, employees all over the world. So when you access from Australia or New Zealand or India or Europe, all of this requests come to the US data center. Typically, that latency is very, very small if you have a good connection. But what happens if you have a very slow connection, network connectivity? So then users might see that they're seeing poor performance in terms of seeing the Power BI report. In turn, it essentially might be a network latency as compared to Power BI. So this is the third one which we have seen. Network latency could play an important factor in terms of where time is being spent. Okay. So those are three large areas what we have observed in terms of you need to be aware of potentially where if there are performance problems that your end users are complaining, these are large areas. Now let's get into a slightly different topic in terms of what storage mode to use. Okay, so there are typically two types of storage mode broadly. One is the import versus a direct query mode. Okay, so largely we are bucketizing live connection and direct query into a single one, right? So if you see in terms of like think of it as a direct query mode where you're directly connecting to the data source. Okay, so in general, we encourage that people first look at in terms of imported mode, right? Imported mode is where you have your Power BI data model. You are importing a list of data sources. We are connecting to a list of data sources. You're importing all of your data. And you have specific limits with respect to shared capacity and premium capacity, how large the data model size can be, right? So the imported mode is the best choice because all of the data resides directly in the Power BI service. It gets served from the analysis services. So when your end users are consuming the data, it's going to be most optimal because the data is coming directly from the Power BI service. There is only one hop, typically only one hop, where the user is connecting from their mobile device or their machine to the Power BI service, right? Overall. However, there are scenarios where import mode is not feasible. I've personally worked with various customers where import mode was not feasible, right? So some examples here, they might have very large data volumes, right? We have shared limits in terms of shared and premium capacity. They might have very large data volumes. So this is not feasible to have the import mode, right? So that is one of the cases. The second one is they want nearly real-time access. So whenever you have the import mode, you need to schedule the data refresh. So some customers want real-time access to the data source. So as and when the data lands into the system, they want immediately see this data. So interact with it. So that's a real-time mode where we would import mode is not feasible. And people have already made considerable investments, right? So they have their data warehouses set up. They have the OLAP models set up. And in those cases, they don't want to go and recreate everything again in Power BI. That's one of the reasons Power BI supports as a visualization layer. If you've already set up this, then you can actually connect to your data source. And our expectation is your data source is well optimized. Your data warehouse or the OLAP models are well optimized so that the queries are very fast overall. And finally, we have seen regulatory requirements where the data has to reside in a specific country, specifically within the country. So think of it as any data that's local to India has to be within the India region, right? So if those are scenarios which you have, you might want to have your data warehouse or analysis services as Azure analysis services residing within a data center within your specific country, while the Power BI layer is a visualization layer, and it can be on top of it. So all your data is locally stored, and you don't have to worry about data getting moved out of your particular country or a region because of your regulatory requirements. So then Power BI is a visualization layer. You need to be aware of it. And these are scenarios where import mode is not appropriate. So we recommend you look at your business scenario and appropriately choose the right option. But we would always encourage first try to do the import mode. Okay. The second one is storage mode requirements. Okay. So typically when you have large data volumes, right? This is data volume that's coming from your relational data source. And typically when you import the data into Power BI, we have seen compression ratios up to even 30x, right? So 30 times compression we've seen. Lot depends on your data and the cardinality of the data and what your data is. As a good rule of thumb, we recommend that you can assume you typically get to 5x to 30x, 10x compression, right? So 30x is what we have seen up to 30x. But like as a good rule of thumb, I always encourage customers to do 5 to 10x compression, so that that's a key factor for you to consider in terms of how you can utilize it. Then if larger than that, then the next step we recommend is, can you use Premium? Because Premium has a larger data capacity in Power BI. Or analysis services. Is analysis services an option, right? So that's the second option in terms of storage mode consideration. The third one is composite models, right? So we have released composite models both in the direct query mode as well as more recently with analysis services as well. See if you can do composite model, right? So that would be the third one before full-fledged going into direct query mode to your data source, right? There might be some limitations in terms of DAX, especially with when you have very large data volumes. Some of the DAX restrictions might apply, and these are restrictions we have imposed so that your end users do not see a very long running query. Like they don't want the report to be running for like 20-30 minutes, right? So that's why there are some limitations with direct query mode. It's very small, but for large scenarios, majority of the customers we have interacted with, that those restrictions are not critical for them. Okay, and that typically applies in a very, very complex DAX calculation. So the next topic is how do you reduce the latency, right? How do you reduce the latency? So in this one, you saw in the previous one diagram and the architecture overview. There are various components there, right? In terms of and network effect makes an impact on this one. It could be data sources, it could be gateways, it could be where your Power BI tenant is located. Okay, so data latency increase and throughput reduced is just simply the laws of physics, right? So when the latency is increased, the throughput is going to be less, and obviously that due to that, you will see your reports a little bit slower, right? So this is just laws of physics, right? So what we have seen formally is if you have a good network connectivity from wherever you're accessing Power BI, we have the network latency typically what I've seen anywhere across the world, right? Maximum of a round trip of like 400 milliseconds, and typically you will not even notice the 400 millisecond delay because typically the reports might load in a minute or two, like a few seconds, like 5 seconds or so. So as you're interacting with it, so when you look at it, it's like in a 5-second report is getting loaded, the 400 millisecond is going to be immaterial, right? So we have not seen that's again the maximum, right? We've seen the network latency as low as 30 milliseconds in some if you're within the same country and you're connected, have good connectivity there. Right, so usually you will not even see this, but as a set of best practices, what we recommend is co-locate all your services. So what we mean by that is if you have your on-premise data source or your gateway or even the cloud data source, can you have these co-located as close as possible? Can you put them into the same data region, right? So or if you have your on-premise data source completely purely on-premise, And can you have your gateway co-locate with the Power BI tenant where your Power BI tenant is? So that's essentially reducing the latency and round trip time between these components. Okay. The next one is on-premise data sources. Can you move them to cloud, right? So if you can move them to cloud with the appropriate VPN connections, then can you co-locate them closer to Power BI tenant? So that reduces the latency again, right, overall. And then if you're using analysis services, can you use Azure Analysis Services directly within the same data center as your Power BI tenant overall? So that's another area which for you to look into. And then the last one is Azure Express Route. So this is essentially one of the customers I was working with in early stages of Power BI. Specifically, like they were getting great connectivity and great performance. The customer was in Europe, the Power BI tenant was in Europe, all the users in Europe were getting great performance. But the people actually, some of the users were in India and they were getting very poor performance. And then after we investigated this, and then we found out that their network connectivity from India to the tenant was the one which is causing this. So then we recommended the customer to use Express Route, and that actually gave the benefit in terms of improving it in terms of Azure Express Route, helped them improve the latency and performance here. Okay, so these are some recommendations. Co-locate the services, see if you can get Azure Express Route. The core intent is reduce the network latency overall. Okay. Now the third area is related to gateways, right? So you want to make sure that your gateways are gateway machines are set up with the right configurations. There is a minimum configuration which we recommend, which you should go and look at from the documentation perspective. What is the minimum configuration of the gateways? But beyond that, we want to make sure that you have monitors with respect to the gateways and monitoring the resource usage in terms of CPU, in terms of network, and make sure that if we need to scale up or scale down or scale out, then you can actually do this with the gateways. Okay, so some of the core scenarios, refresh or direct query performance is bad. This is something which you have seen, but not in desktop, right? Desktop, you do the refresh or the direct query, everything is simple. And then there's single gateway used for both direct query and scheduled refresh, right? So this is the common scenario which we have seen working with the various customers. Now, why is it undesired, right? So the way gateway is structured, all of these incoming requests, they get queued up and they can occur concurrently during the scheduled refreshes. But if you're overloading the gateway system, then the gateway needs to push through all of these scheduled refreshes. And that could potentially cause a bottleneck, right? And then it doesn't allow optimization of gateway for specific scenarios and times. This is especially if you want to have all the scheduled refreshes scheduled and you are expecting all of the data to be arriving in the Power BI service when people come in and log in at 9 a.m. in a particular location, right? You want to make sure that the gateway is not the bottleneck here. Okay. So proposed solution here, essentially, like again, use the enterprise gateway and a minimum of 8 cores and 16 GB RAM. And also consider splitting up the gateways. So what we mean by that is if you have all the direct query related gateways like analysis services or direct query, can you put all of the direct query in one and scheduled refreshes in another one, right? Another gateway, split up into two different ones. It's much more easier for you to monitor, understand the root cause of the problem, because if you have one single gateway, these might be conflicting with each other. And you don't know where the issue is, right? So that's one approach which we recommend to various customers and which is proven very beneficial for several of the enterprise customers is all the direct query related connections in one gateway and scheduled refreshes in another one. Okay. Set up monitoring. You can set up monitoring from a gateway perspective. We have various levels of monitoring in the gateway, and you also have a performance monitor on the core resources. Then you have the option to scale up or scale out as and when you need performance, depending on the impact here. Okay. And so again, there is a perf monitoring information which is released last year. That's a great way for you to start looking at it. And you do need to enable the config file to get like much more information about the configurations overall. Okay. And you also have a Power BI template so that you can analyze all of this gateway data as well. Okay. So this is the second topic in terms of we covered the storage mode, we covered the network latency, we covered now the gateways and optimization. Finally, in terms of query caching. So we've communicated a little bit in terms of there is caching involved in the service. You have the option to do it. So some of the scenarios is if you want some of these reports to be very fast, as and when the users come onto the dashboard, have the premium frequently used report on premium. So if you have premium capacity created, if you want these reports, like the execs are using a set of reports, then consider premium, right? So and then also, can you do infrequent refreshes, right? 1 to 2 times a day, right? So overall, so this is what do you do in those particular scenarios. And then reports slow down due to high usage and query complexity, right? So these are the 3 common scenarios which we are here. And while the proposed solution here is turn on query caching for the data set, right? So there is a feature called query caching, so which is in terms of the direct query setting, which you see here as part of the right-hand side in the diagram. And typically by default, the capacity query caching is turned off. Now you can enable this. This enables Power BI to cache some of the data as and when the data gets refreshed, and then actually control the refresh frequency of this cache so that all of this data gets cached in the Power BI service. So then you don't have to use premium or some of the data is like a little bit slower. You avoid all of these. So by enabling query caching, you enable some of the optimizations which we have done on the Power BI service so that multiple users can leverage the query caching, assuming it's no row level security and the data is not unique. We try to optimize this so that all the users who have to see the same data very easily see the same data, and you get benefit in terms of avoiding very high in terms of usage resources. Okay, so this is the last topic in terms of leverage query caching as a functionality. Okay. So this helps in terms of just understanding a little bit of the overall architecture, and then some of the solutions in terms of going through how do you architect the solution within your organization. Okay. With that, I'm going to hand over to Phil for the data modeling section.
Cool. Thank you, Siva. So now we're going to talk about data modeling and how that can impact on performance of your Power BI reporting. And absolutely, if you can have a bad data model, if you have a bad data model, then that can certainly break the experience. So it's vital that you make sure that your data model is efficient, even on small data loads, because while you're developing over maybe a small data set and it could appear fast, by the time you load that onto the service and you have a lot of users hitting that, then a poor data model will result in making your server a lot busier than it needs to, and obviously providing a slow report experience for your end users. So what we're going to do today is first just talk a little bit about analysis services, and then give you about 8 tips on some things that you can consider when you're building your data models. So why are we going to talk about analysis services? Well, analysis services is the database engine, the technology that Power BI reports are built onto. Analysis services has been around for a long time. We're talking the earlier flavors of analysis services, were built 20 years ago, and Microsoft have been doing this for a long time. So there's a lot of experience and good things baked into the modern analysis services product that Power BI uses. It's a database that has been optimized for reporting and analytics. So it's quite different to the database technology that you might be used to with, say, SQL Server and other relational databases that need to concern themselves with things like inserts and updates and deletes, single line stuff. Whereas analysis services, typically with reporting and analytic workloads, are taking very large queries. I want to know how much did I sell for an entire year, and going for very much a top-down type approach. So even though it's a, because it's quite a different technology to other database engines, there are things that you can do to make sure that your data model is optimized for the analysis services engine, and that's what these tips are going to be. I mean, it is fast. It can be incredibly fast. You can run queries over hundreds of millions, if not billions, of rows of data in just seconds. Simple queries, so long as the data model has been optimized. So let's have a look at some of those tips. So the first tip. Oh, no, that's not the first tip. We're just going to be talking about pretty much what I've just talked about, the high level stuff. An inefficient model can definitely slow down a report, even on small data volumes. So definitely one of the goals are to try and make the model as small as possible. It might seem a little counterintuitive, but analysis services heavily relies on compression. And the more compression, the better. In other domains, usually lots and lots of compression can be a problem because you need to uncompress it before you can do anything with it. And if you have a incredibly a powerful compression algorithm, then that might take a long time to compress, but it'll take a long time to decompress. The beauty of analysis services is once the data is compressed into the model, it doesn't need to compress. It can actually take your queries and go and answer them, get the results required, over the compressed data. So generally what we're trying to do is maximize compression, make the data model as small as possible. And obviously the schema needs to support the all the analysis that you want to do. Quite often we might see models that bring in just all data, left, right, sun, everything that they can see, and it brings in a lot of data, but it doesn't necessarily fit the requirements or the needs of your end users. So definitely recommend requirement-based goals for designing your models, and that you think very carefully about the relationships between tables as well. So put some thought into what relationships you need, what kind of relationships they need to be, and definitely don't try and just replicate the table structure from your source, because that's probably been optimized and designed to support the application that the data is coming from, not necessarily to get the best out of analysis services compression. So tip number one is to aim for your star schema. So you may or may not have heard this technique, but the star schema refers to the layout and structure of your table system. So what we typically try and do is we will organize tables to be either what we call a fact table or a dimension table. Fact tables are usually transactional tables that represent business entities, things that we want to count, such as transactions, sales, orders, inventory, and things that actually take place. These are business entities. While dimensions are usually the tables that control how you like to slice and dice. So the number one dimension table that typically goes into most data models is some form of date or time dimension, so that you can organize your facts by day or by week or by year or whichever. Other common dimensions are around item or product, perhaps store or geography, but there are many more that might be unique to your business. But what we try and do is have these organize our tables into fact and dimension tables. And yeah, there's an element of denormalizing, which again is almost the opposite of what you're trying to do to your table design from the source system, which is usually supporting an application. And we really try and minimize the number of joins that are required to resolve a query. So what we don't want to have is a query being generated by a Power BI visual that needs to connect up about 20 tables. That's going to potentially be very slow. Whereas if it can get the data that it needs from just 2 or 3 tables with minimal relationships, then you'll definitely get a fast query experience. So here's a diagram of showing the star schema. So here we have the classic, in the diagram we have a fact table in the center, and it has a relationship out to a number of dimensions, and this is why we call it a star schema, because it looks like a bit of a star. Now, you may only have one fact table in your model. It's quite normal to have multiple fact tables, and one of the beauties of this design is that dimensions are often common per fact table. So if you make a slicer selection to say that in my date dimension that I only want to consider rows that are relevant for 2020, then that will filter down to any fact table connected to that, down to the sales table, down to the order table, down to the shipping table, or whichever, and it just happens automatically. What I recommend you don't do is try and connect fact tables to fact tables. That's a bit of a red flag. If you ever see a diagram with a fact table with a relationship to another fact table, then there's opportunity for that data model to be optimized. So we talk about the STAR schema. We use the Kimball 4-step process. So you go and identify your business process, in this case, sales. You nominate what the grain is. Now that might be one item, one sales line per basket or transaction, or it could be the products within the basket. You then go and identify the dimensions that are relevant to that. So how you like to group or filter the facts. So in this case, we have, date. There's some people ones in terms of worker, product, where you have product category, subcategory, etc. Supplier, where the product has come from, and office, which is, could be a geography. You could have this, city, country, hire, etc. And then within the fact table, you normally have a series of numeric columns with values that represent perhaps the quantity of items that was sold, the price, the discount amount, the tax, and these things can be quickly summed or, involved in DAX calculations to, perform your analysis. But that's the pattern that you go for. And if you make the effort to get your model in this shape, then a lot of things will just fall into place for you. Queries will be a lot easier to write and they will run faster. There's a little bit of an overhead at the start loading data in, but it's well worth the effort to structure your data. Now, with small data sets, you can build models that don't use this format, and they can run very quickly. But what you're doing is you're actually masking the problem that might come back and bite you a little later in the day once you get a lot more data going into that model down the road, and it gets popular and you get a lot more users hitting it. Then by what appears to be fast early on might be a problem. Whereas if you apply the STAR schema, then it's going to be a lot more robust if and when you get more data and more users. So a really good tip as well, once you get the STAR schema applied, is to make sure you remove any unnecessary tables and columns. Quite often when people are starting the data model journey and building something from scratch, they connect to their data source and say, hey, just give me the entire table. Give me all the rows and give me all the columns. And these tables could be quite wide. And what I mean by wide are the number of columns in that table. And you might be bringing in 100 columns. But then once you've built your reports, you may find that you've only actually ended up using half a dozen or up to 10 columns. Now, unfortunately, those unused columns do have a cost. They affect compression. They affect the time it takes to load the data into the model. They affect the refresh time, and they can actually have a negative impact on query speed. Not too much, but completely unnecessary. So, not only do I recommend the exercise once you've done a lot of the work to build your data model and your reports to identify which columns are now unnecessary, because you can bring these columns back in later on. And there are some very good tools around, third-party tools that you can run over your system to say, hey, based on the number of visuals and filters that you've used, here are the columns that are involved, and importantly, here are the columns that aren't involved, and that could be a good opportunity to remove those. But equally, I highly recommend that you consider what rows you bring into your data model. Just because you have 12 years of sales transactions in your data source doesn't necessarily mean you need them in your data model. So what you could do is say, hey, I'm only going to bring in a year's worth and start dropping things out as well. Do I need a date table that goes back to the 1st of January 1990 and finishes on the 31st of December 2099? Probably not. So making sure that you optimize the tables in your model, not just for columns, but for rows as well, can have a big impact on the data size of your model, which then flows on to the other important elements as well. Another really important tip that I strike pretty often is to avoid bringing in high precision and high cardinality columns. So what's a high cardinality column? A super high cardinality column is a column that has a unique value in every single row of that column. And again, going back to source systems, it's a very, very common way to organize data. You have a primary key or an auto number type field in most of the tables, so that when you add a new row to that table, it generates a unique value to allow that source system to come back and easily update and delete and at row by row. Now with analytics and reporting, that particular column not only becomes practically useless for reporting. It's not typically a column you want to do sums and averages over, but it gets in the way of compression because you just simply can't compress it if there's a unique value there. The other column that we recommend you consider fixing are high precision columns. So again, when you've got perhaps a column that not only has the date, hours, and minutes, the date in years, months, and days, but it also has on the same value hours, minutes, and seconds. So for every single transaction, which in effect becomes a highly unique column, and it's a column that you cannot compress. We will accept it. We'll load it. We will load it into the data model when we're refreshing it, but you don't get very good compression. So your model sizes will be much larger. So a really good tip that you can consider when you have a column that has hours, minutes, and seconds, separate it out into its own column. So that you have years, months, and days in one column, which does compress to a degree, pretty well, particularly if you have a high number of transactions per day. And then if you need hours, minutes, seconds at all, put that into a different column and maybe get away with just say the hour, what hour of the day did this transaction take place, so that you can create some nice hourly grain charts to show, the day getting busy and when the peaks and troughs are through the day. Some other columns that you can consider looking at are the decimal columns. We provide a fixed decimal and a standard decimal. I think standard decimal is accurate to 300 decimal points or something quite ridiculous, whereas fixed decimal is accurate to 4, which is perfectly fine for currency and financial type applications. So making sure that you choose the appropriate data type there will make a big difference on the size of the model, and equally the time it takes to refresh it, because as I mentioned, compression is very, very important. And these high cardinality columns get in the way of techniques that we use called run length encoding and bit packing to help compress the model. And just touching on what I mentioned before, actually just removing columns if they're not needed is a really big thing that you can do. It's not uncommon for me to see a model. I'll look at it and say, can you remove columns A, B, C, D? And and we do that. The model becomes half the size, loads in twice the time, and the end user can still perform the same analytics and reporting that they could do without those columns. Definitely be careful with bidirectional relationships. So with Power BI data modeling, when you create a relationship between two tables, you've got the ability to specify whether it's a classic single direction, i.e. when I select a value in my dimension, that filter will propagate down the relationship and filter any fact table connected to that. Remember, you can have multiple fact tables, and that works well. But you can turn on that relationship to be bidirectional, which means if you apply a filter to a column in your fact table, which potentially could be very large, then that filtering can go up to your dimension table or any other table that's related to that. Now, that might appear to solve some situations, but it can come with a performance cost. And I have yet to see a bidirectional relationship that could not be modeled using single directional relationships with a different data modeling technique. So by all means, if you're building a brand new model and you notice that all the relationships are bidirectional and you're not specifically using it to solve a problem, then I highly recommend you consider turning those off, make them single directional until you get to the point where you're not getting the results you need. And let's say if you turn on bidirectional, it gives you the results you need. At that point, you should consider researching what are the correct data modeling solutions or alternatives to that, because that's going to have potentially quite a performance impact. And as the proposed solution says at the bottom here, only use BiDi where the scenario really requires it. And even then, I think you could remodel and find that you could remove it totally from your system. But if you need to do something quick, fast, then perhaps fine. But test, double check, because you can actually get with bidirectional sometimes unexpected results. So definitely test there. Consider composite models instead of pure DQ. So pure DQ might mean you have a data model with 20 tables, and every query, every slicer, everything you do is converted to an external query that gets sent out to your data source, which may or may not be nearby. and there's going to be latency. There's going to be a cost for that. It doesn't matter how fast your data source is, it's not going to be as quick as import. But there may be very good reasons why you don't want to load all of your tables into import. So we have the luxury of being able to pick and choose. And the composite model architecture, what works pretty well is relating to the star schema approach that we talked about, is set all your dimension tables to run as dual. Which means what we do is we keep an import version of that as well as a DQ version of that. But then your small fact tables, maybe import those if you don't need near real time, and maybe your large fact tables you can leave in direct query. And just that scenario there means when you first load the page, your slices will be quick because they're issuing queries that don't need to join to fact tables, so they can get the data they need from the cached imported data, so they'll be very fast. And then only queries that rely on grouping by columns in your or dimension table that need to perform some metrics over the fact table will get pushed out to the source. But a really good thing to consider here is aggregations. So what you can do there is create a set of summary table or aggregate tables, bring those into your system as import, and ideally when you first load your report page, all of your queries, all the visuals on the report that you care about can be satisfied from the aggregate tables or the slicer tables. And it's only when the end user then starts to drill down to the point where the query can't be satisfied from one of the aggregate tables by grain, then it can escape out to the data source. And you're hitting the data source a lot less at this point. So it now has the ability to cope with the query load a lot better. And you can mix and match. So it's a very good architecture that we see used successfully in many customers. And this is on small, medium, and very large models as well. So definitely have a good look at composite models instead of a pure DQ system. So with that, I'm going to hand it back over to Siva, who's going to talk about dashboard optimization.
Yeah, thank you, Phil. And one of the reasons why Phil spent a lot of time in the data modeling optimizations, because that's one of the areas where we have seen a lot of performance issues because of choosing the wrong choices. So it's critical to focus on the data modeling section significantly. The remaining sections, we have like 5 different topics still left in this session. We'll cover 4 of the topics predominantly, but like these are things which we definitely want you to do. But the key focus is make sure that like data modeling optimization is going to be very critical. Okay. Now moving into the next topic, this is part of the visualization optimizations, right? So the first thing is dashboard. So you are predominantly sharing dashboards. You have the ability to share dashboards and reports. But the key topic here, first we'll cover the dashboard and then Phil will cover the report optimizations. So from a dashboard optimization perspective, so when you look at this picture, this is where the dashboards and reports are coming up, right? So the dashboard aspect of it, the dashboards are aggregate of visuals from multiple reports. That's where users come in and get a quick glimpse or a glance of all the key metrics for the organization. So think of it as you are going to an ICU where the key metrics of a particular patient are like heart rate, pulse rate. These are, you can think of these as dashboard metrics. So there's very quick information about how the patient is. Think of that as the dashboard. And then when you dive in deeper in terms of I want to go and look at analyze the patient's much more detailed blood report or something, you can think of that as a report, right? Because that you have a lot of list of things which you're looking at. So dashboard is a quick way for you to understand about the key metrics of your organization, the health of the organization or health of the product, how the organization is doing. Okay, so how we think of it is dashboard is to provide a very quick summary with drill down into reports, right? So a very quick summary in terms of how are my sales doing, right? Are my sales increasing or decreasing? Am I below target? So that should be a very short summary in the dashboard represented by a visual. So then if you need to go and do additional analysis, then we want to make sure that you are drilling into a report which is interactive. You can go and do further analysis, right? So that's how we think about the dashboard. Okay, so we want to make sure as part of this, you want to make sure that you are employing the right design principles for the dashboard. and you're also doing appropriate caching because Power BI provides the ability to cache things on the dashboard, so that you are actually using the caching technique in terms of Power BI. So when the end users come and look at the dashboard, these are actually fast, okay, in terms of how the load of the dashboards. So one of the scenarios with respect to Launchpad design, right? So what we have seen is some of the dashboards we've seen when working with customers have very detailed values, right? Why is this undesired, right? It limits the usability and causes a creative excessive load, right? So especially when you have too much amount of detailed data in a particular visual, then all of the data has to be captured, obtained, and stored. And also when you're looking at this in mobile, it's very hard to read, right? So try to make sure that you are using a design that it's a summary view. It's very, very simple and easy for people to understand overall. Okay. Now, the second one is what we've seen from several customers is they want to have a single visual report tiles, right? So what we have typically seen is they want to group a set of visuals in Power BI. So they typically will try to create a report page, which mimics the size of the dashboard tile, and they will pack in a lot of visuals. Okay. And then they'll print this as a report tile, live report tile into the dashboard. And we've seen this both internally to Microsoft, various teams, I was architecting solutions, as well as external customers. And when it is actually executed, it's still a live report tile. And then Power BI, because it's a live report tile, it has to go and fetch the data. And it is not cached. It's a live report tile. It has to go and fetch the data when the user comes in. So you will see that the dashboard is loading very slow. So several customers actually said like it is very slow. So what our recommendation is, when you have a dashboard, do not have more than one live report tile, right? Do not pin more than one live report tile because it has to go and fetch the data. That's the official recommendation. So one of the technique, a couple of techniques in terms of what we have proposed solution is try to see if you can aggregate the data appropriately to the end users. The other approach is create a custom visual. So when you create a custom visual, all of the data packed in for that particular custom visual gets queried, and it actually gets cached in the Power BI service. So that's where you will be able to find out that you get a better performance. So these would be the proposed solutions when you want to group a group of visuals and you want to show this in the dashboard. We would encourage, if it's super critical, then create a custom visual as part of that. Okay. And then the next one is avoid very busy live report tiles, right? So if you create a report tile which has a lot of metrics packed in, so then at the time when the dashboard is getting loaded, the data for this live report has to be queried, right? So then what will happen essentially is it has to go and query all of this data. Let's think of it as you have a live report with 50 visuals, right? So when we actually go and query the data, we try to avoid overloading your backend system. We open only 4 at this time. We open 4 queries and get the data, right? Depending on the latency, the entire visual, it has to do 12 round trip overall. If you have like 13 round trip because you have 50 visuals, then it becomes very poor in terms of the performance. It can take more seconds in terms of just the dashboard load time, right? So proposed solution for this, pin the individual visuals directly into the dashboard so that, and again, find out what is super critical for you to look at it from a glance. And then design metrics of the dashboard, make sure you try to address this from what the user wants, right? Usually they typically may not want all of these reports, all of these visuals in the report type, right? So typically they might want like a few metrics which are critical to them, and then make sure that you educate them to drill into the report if they want to go and look at it. Okay. Then the third one is manage direct query dashboard cache refresh. So this is the third one where you have a direct query setup. By default, the refresh happens every hour. Okay. Now, obviously, when you have a direct query model that's set up, and if you have like tens of hundreds of dashboards querying this actually creates a lot of refreshes that are happening in the Power BI dashboard. In some cases, it may not. When a user comes in, the data may not be there. It has to go and fetch the data, right? So you can actually control this, even though it's a direct query. The dashboard, the reports are always live. What you can do is you can set up the refresh frequency. If you know that the data is not going to change, or it's going to be less critical for the customers to see the recent data, what you can do is you can actually change the refresh frequency. You can, by default, it's 1 hour. You can change this to 6 hours, 12 hours, or even a day, depending on what when the data getting updated. This will help in terms of when the users are coming into the dashboard, they always see the latest one. Okay. With that, I'm going to hand over to Phil for the report optimization.
Cool. Thank you, Siva. So I'm now going to be talking about the report optimization side of things. So the point in the diagram that we're going to be focusing on here is just above analysis services. So what can we do on the reports themselves to help make the experience nicer for all our users? So at a very high level, probably the main tip, and I have got several tips here for you, is going to be focusing on the visuals. So you have to remember that visuals generate queries against the data source, and even consider the analysis services imported or cached version as a data source. And one visual can create multiple queries to that as well. And if you're in DQ, think about running one visual sending, say, 6 subqueries out to a data source such as a SQL engine. But you absolutely have at least one query per data-driven visuals. Queries are sent in parallel batches, and just to design a report that has 60 visuals on it, what you probably don't want to have happen is when the end user opens that page, that all 60 queries fire instantaneously at your data source. That's going to overload any system, and multiply that by 10 people or 50 people who are all opening a report at the start of the week, for example. Equally, inappropriate use of visuals and slices can generate very large queries, inefficient queries, and slow the whole system down. So what we're trying to do is reduce the number and complexity of queries, and we're trying to optimize and simplify the amount of data that gets returned to the report. And there are some tips around how you can identify slow visuals in DAX using the Performance Analyzer tool. So probably the most important tip is this first one here. Ideally, we should consider limiting the number of visuals on a page. If you've got more than 20, that's probably a lot. That's going to be very busy when you first load the page. Remember that every single visual, even ones without data, have their own overhead. They have JavaScript file local to that visual that needs to talk amongst all the other visuals to figure out what's going on with cross-highlighting, and that can get very chatty and very noisy for your client experience. So we really want to simplify that. And many queries can certainly overwhelm the data source in a high concurrency environment as well. So what you should consider doing is try to limit pages to 8 visuals or less. There are exceptions. If you know for sure that everything's nicely tuned, then sure, do that. But quite a common pattern that I see is maybe a report with a whole bunch of card visuals aligned horizontally or visual that give a different KPI. Now, if you have 5 or 6 of these can actually be consolidated into a single visual. You could use a matrix visual which is a single visual, to have each of the 5 or 6 measures that you were previously using on the cards. You can turn off backgrounds, you can size it and set the formatting, but place it over a hard-coded background with a pre-configured image so that it looks like what you previously had. And 6 visuals down to 1 can make a big difference in report loading. The other thing is, of course, is within visuals, when you have a query for a visual execute, it has its own equivalent of like a select and a where clause and filter that it gets sent back to the underlying source. It can be very similar to other visuals, but we treat these independent. We treat these as separate queries, and we go and do all the work for that specific query. But then in a similar visual, it has a very similar where clause and a very similar select clause and a very similar join statements. Now, if you are able to combine these into a single visual, then what we can do is we can fuse a lot of this work together and go get all the data we need in one step to satisfy or perform the calculations that we need. So there's some quite neat things you can do there. Set defaults, filter and slicer selections to limit context, just to reduce the number of rows we're talking about. And you can use drill through in a smart way to get through to your additional visuals that perhaps were previously on this page. And the end users, can have a fairly good experience. Yeah, and absolutely. Combining multiple cards into one, there's a number of benefits there in doing that. You should always review the visual interactions. So there's a screenshot here showing the feature. Every single visual has the ability for you to control how it affects all the other visuals on the screen. By default, it's on. But what you can do when it's smart to say, hey, I have a visual over here that when I click on it, I don't want it to change another visual on the page. So you can go in using the edit interaction feature to turn these off. And the more you turn them off, the faster your report will be, because that chattiness I mentioned earlier can be reduced potentially quite significantly. So certainly disable meaningless interactions. Yeah, use filters to limit. So if you have a table with a table or a matrix with many thousands of rows, then filter it to what's relevant and what's required. Use the drill through, use top in. There are ways that you can make the report load faster, but still provide the end user to then drill down as required. Using the plus button or right click and drill through. So that can definitely speed things up significantly on your report page.
So here we're going to focus a little bit in terms of when you're doing the data loading and refresh, what are the optimizations that you need to consider here? Okay, so you've seen this diagram where specifically you have various different data sources. You are going to be connecting in the direct query mode or importing, and specifically when you say data loading or refresh, this focuses on the import mode, right? So here you have the analysis services, you schedule a refresh, it's trying to go and get this data directly from the backend related data sources. It could be cloud or it could be on-prem. Okay. So at a high level, so when you're doing data loading, you are essentially using Power Query. The language which is being used is M, and you are doing data transformations, right? So it might be a simple road, but you might be doing a lot of data transformations as you're loading this data. So Power Query offers a very point and click solution where you can easily transform the columns, split the columns, various things, and it orders the list of steps, right? So overall, now these may or may not be optimal, right? So in terms of how you are actually going and doing this, it may not be optimal. At the end of the day, what the goal we want to have is all of this transformation as much as possible. We want to push all of these to the corresponding data source, right? It could be SQL, it could be SQL data warehouse. We want to push all of these transformations to the data source, so that's where you do a lot of these transformations much more faster, right? In cases where you're not able to push this, then Power Query has to import all of this data and then do these transformations, right? So that typically can take up significant memory in CPU. And that's where you will run into some performance issues. Okay, and the second area is primarily we'll get into a little bit of details on the Power Query in the coming slides. But before that, I want to cover one more topic in terms of data loading and memory. Okay, so you have something as the model memory overall, right? So this is you have a PBIX file that's getting stored we typically encourage, that's a good rule of thumb in terms of estimation of the data model. So in theory, when this data model gets loaded into analysis services, that model size is actually not equivalent to the model size on the disk, right? So we actually compress a lot of this data and the indexes, and these when it's loaded into the memory, this is typically can be like 10, 15, 20% increase in terms of the memory size, right? This is for you to be aware of. When you're loading a 1 GB file into which is a disk file of PBX file, when you load this up into analysis services, it might be 1.1 gig, right, overall. Now, why is it important? So one is when you're doing a full refresh, you need to have the analysis services like 2x the memory of the model, right? It could be 1.1 gig. When you do a full refresh, the analysis services needs to actually include the entire 1.1 gig. Once that is finished loading up and it's committed, then it can remove the second one. So you want to make sure like you're aware of that, especially in the premium capacity. When you have your own capacity, you are very familiar with that one. Okay. And when you're doing some of the thing complex or inefficient Power Query, that memory need might even be a little bit more than what normally is, right? If you have complex Power Query calculations, which cannot be pushed into this. So keep this in mind in terms of when you're doing memory refreshes. Is it full refresh that you need to do there, and how is the memory going to take time, space overall? Okay. Now, one of the things we talked about earlier is we need to be pushing as much of these operations directly to the source, right? So this is on the right hand side, you see a diagram with respect to a Power Query window where you're applying a various list of transformations. Whenever you see this view native query, that essentially means that all of these transformations are folded, right? What we mean by leverage query folding is all of these operations which you've done are getting pushed directly into your data source. So it's going to be the most optimal technique, right? So you want to make sure that all of these are pushed directly to the data source. So keep that in mind and make sure that you can right click and check whether you see the view native query. Whenever you do not see it, that means that things cannot be pushed, and see whether you can reorder to appropriately get all of these pushed. Okay. Now, what type of data sources can it be folded? We have a short list, but it's not fully complete, right? Relational data sources, O data sources. These are some of the things what data sources where we support query folding, and what are the operations which we do, right? So this is essentially the operations in which where we can do query folding, so that like we have the optimized query to send to these sources to make sure that it can be folded. Now, a little bit additional tip: avoid scanning the entire or whole table, right? Especially when you're doing like grouping, aggregations, merges. This is typically is an entire full table scan, right? And if this is not folded, then essentially what it would mean is then the memory at the time of the data load can become very, very complex, right? So as part of the proposed solution, see whether you can consider writing this in DAX to achieve the same result rather than doing it in the Power Query window, or can you customize the query, because you may be an expert in writing the SQL query a little bit more optimized. The system tries to do it in the best possible manner, but you may be a SQL expert. In those scenarios, can you go into the advanced editor mode in the Power Query editor and make the query appropriately, right? So that way, you know, this is a well-optimized SQL overall. Okay. The next technique is do not load intermediate queries, right? So we've seen several customers actually form several queries which are intermediate queries, right? They form these intermediate queries so that they can do a final query overall. So if you have such intermediate queries, which is all good in terms of for you to make sure that you are optimizing in the Power Query editor, like much more easier for you to understand. Avoid enable load, right? So that way, when you click this, disable this enable load, then that query is not getting loaded, and that helps in terms of the amount of memory that's being used in the at the time of data refresh to be minimal. Okay, and finally, you want to make sure that you turn off auto date time, right? So this is super critical, right? So you have a date time column, and the default setting is on. And now if you do auto date time, essentially what happens in the Power BI is it is creating internal date table. This can significantly increase the memory or the size of the data model. Okay, so if it is important and if it is needed, you can utilize it. But in most of the scenarios, what we have seen is they typically have a date range starting from a specific year. You don't need to do the auto one. So disable the auto setting, and you can create a custom date table, achieve the same exact functionality. That way you're saving precious memory in the data model that you can utilize for loading other fact data overall, right? So this would be the last one. So we covered a little bit in terms of data refresh and data loading. What are the various techniques in order to achieve this? So in terms of the performance management framework, we have a few slides. I'm going to skim through this very quickly and get to the conclusion. But these are things which you want to be looking at as you are going through in terms of creating a Power BI dashboard and report for your users. Where do I focus on, right? Think of performance as coming right from the beginning when you're architecting the solutions. Start this performance. You have learned the various components which are there and which can affect performance. Start from the visual layer, right from the business users, and then go into data modeling, and then how you are architecting the solutions. That's one of the critical ones. And measure the performance. So primarily, first, when you're authoring these reports, find out what is the performance in the Power BI desktop. That's a scenario where you don't have any direct interactivity with respect to the cloud or network. You are directly, you know that this is the best performance you will see in terms of the Power BI desktop. And if the performance in Power BI desktop is very slow, then moving to the service is not going to magically improve it directly. Okay. So you want to make sure that when you're doing it in the Power BI desktop, evaluate the performance, get the baselines, and make sure that you have a good understanding and set expectations to the end users you're working with. And build performance management into your entire solution lifecycle, right? So when you're authoring the reports and dashboard, measure the performance, create the baselines, look at how do you discover regressions which are there, because as the data increases, the performance might be lower depending on whether it's a complex calculation. So you want to make sure you set this up appropriately. Again, not a big problem in terms of when you're sharing it with a set of users, but when you have like some of these reports getting shared with tens of thousands of users, you want to make sure that you're building into a performance management framework as part of your end-to-end solution as well. Okay. And as and when one of the key things in terms of sharing, in terms of you want to make sure that all your users, so if there are self-service users or enterprise BI users, all of the things which you learn, how do you divulge this information within your organizations? Make sure that you are using certain specific modeling guidelines which are common, educate the users, and make sure you have a thorough review in terms of performance as well. And make sure that everyone is aware of how do you optimize, right, overall, right? That's the key thing. And with that, I'm going to just summarize what you learned in today's session. Performance tuning can be complex and can take time, right? So Power BI provides all the tools in terms of interactivity and making it simple and easier for authoring the reports. But depending on what choices you make, then the performance tuning can become very complex at towards the end. You want to make sure you're approaching this systematically and doing a data-driven approach in terms of tuning the performance, and start from the beginning, right, as you're architecting the solutions. Okay. And depending on what your business needs are, you may need to make some trade-offs overall. There are several tools that are available in terms of the desktop performance analyzer. You have various features like composite models. Leverage these things, right? Make sure that you are leveraging several of the features and based on your business requirements overall. And that's where we want to end with. Hopefully you learned in today's sessions in terms of what are the various key pieces where performance could have an impact, and how do you go and architect the right solutions and right trade-off to get the best performance for your end users overall, so that they are seeing you as heroes in terms of using Power BI. Okay. With that, I'm going to stop, and thank you everyone for joining for today's session. Hopefully we've answered these questions dynamically in the chat window as well. Anything you want to add, Phil?
No. Thank you all for attending and listening, and yeah, that's all I've got. So over and out.
Thank you.
Okay, so you can stop.